Yo, 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 what's up, all you cool cats and kittens? Meow. Topic 5 review. Let's do this. Given that M is the midpoint, hi M, you're the midpoint. That means something to me, all right? So that means I would put like little tick marks on this segment, boop, and this segment to show that M is the midpoint. So that'll be useful for things like medians and perpendicular bisectors that have to touch the midpoint. All right, identify the following special segments, starting with AL. All right, AL, let's find you, AL. From A to L. All right. Well, I do see the right angle there. So I know that it's something that's going to be perpendicular. So that could either be a perpendicular bisector or an altitude. Now, because that goes from the base to the vertex, I know that that's going to be a altitude. If it were a perpendicular bisector, it would have to go through point M because point M is the midpoint. So AL, you're an altitude. Up next is AM. All right. Well, AM goes from the vertex A all the way to M, which we said is a midpoint. So because it's going from a vertex to a midpoint, that's kind of an easy one. That's our medians. And that was like our favorite segment was the median. That's the one that we did in class where we made the triangles and we balanced them on the tip of our pencils or fingers or whatever we had. Up next is AP. AP goes from A to P, and P's not anything special really. Nothing crazy going on with P. It's not the midpoint. It's not perpendicular, but I do notice these markings on AP. So that tells me that AP, because it has those markings that we see at the angle here, those congruent arc marks, I know that AP is an angle bisector. So you might notice that we're concerned with all the markings, like the right angles, the arc marks, the tick marks for the midpoint. Those things matter to us. And up last here we have QM. QM goes from point Q, which doesn't look that special, to M, which is the midpoint and has a 90-degree angle. So QM, midpoint, 90-degree angle. 90-degree angle tells me perpendicular. Midpoint tells me that it's bisected, so QM is the perpendicular bisector. Cool. Up next, an ice cream vendor wants to be located equidistant from 2 points. So just thinking back to my definitions, equidistant to 2 points, I know that the answer is perpendicular bisector. That's like the one thing that we learned about a perpendicular bisector. If I have 2 points given to me, all right, there's my 2 points. Here's a zoo and an amusement park, according to the question. I know that any point on the perpendicular bisector, any point, so maybe here, is going to be an equal distance to both sides. Maybe it's here. It's still an equal distance to both sides. That's the only thing that we learned about a perpendicular bisector. No matter where you are on that perpendicular bisector, you're going to be equidistant. I said sides, I meant endpoints. You're going to be equidistant to both endpoints. So since I'm equidistant to 2 points, a zoo and an amusement park, I know that it's a perpendicular bisector. Perpendicular bisectors are equidistant to 2 endpoints. All right, guys, so perpendicular bisector, equidistant to 2 points. Next up. List all the special segment names that apply to PS. All right, cool. Well, right off the bat, I see that PS is perpendicular and it goes to a vertex. So automatically, I know it's an altitude. Altitude. Spelling's hard. All right. I also notice that we're equidistant to each endpoint. So those tick marks tell me that I'm equidistant to each endpoint. So I also know that that's a perpendicular bisector. PS is a perpendicular bisector. All right, all right. And I also know, because this is an isosceles triangle, I also know that I've got that this perpendicular line is going to split that angle in half. So I also know that PS is going to be a angle bisector as well. All right, and I know that also because I can use my triangle congruence. I see a, oh snap, I would have what, side, side, side triangle congruence there? Because I've already proved that it's a perpendicular bisector, so I know that these segments are congruent. So I know that the two triangles are congruent, so I know that these angles, I'm going way too in depth here, but because it's an isosceles triangle, that PS is a lot of things instead of just one thing. All right, isosceles triangles work like that. Find the value of n in the length of QR. Show your work. All right, so this is the one I was throwing a hissy fit in class about because we couldn't find the angles correctly. So I'm going to show it here, and hopefully you get it. X, W, Y. Starts at X, has its vertex at W, and goes through Y. So the vertex is W. So that angle right there, that angle right there that I'm marking up is 15 degrees. So if that's 15 degrees, I need to find the angle ZWY. So ZWY starts at Z, goes to W, and then to Y. So it's this angle, and you know, if you have eyeballs, then you know that that's 15 degrees as well. And then last up, find XWZ. XWZ goes from X to W to Z. It's the Big Papa. It's both of those angles together. So it's 15 and 15, which make 30. I just noticed that I didn't finish the last question. We got to find the value of n. So I need to take the 6n plus 3 and make it equal to 4n plus 11. So, oops, I almost forgot that. All right, so it's going to be what? 2n plus 3 equals 11. Subtract the 3. See, algebra never goes away. 11 minus 3 is ocho, as they say in Puerto Rico. And n equals 4. So n equals 4. So if n is 4, then QR, ooh, okay. So n is 4, so that means that's 4 times 4 plus 11. So 16 plus 11, 16 plus 11, big math, 27. 16 plus 11. So this piece is 27, which means this piece is 27, which means QR must be 27 plus 27. 54. 54. All right, cool. Last part on this section, label each of the following points. Oh, I love this. All right, well, I know this one's got a circle on the outside, so that's a circumcenter. Circle on the inside, incenter. And when we name the points, we're naming these points of concurrency right here. All right, this is where 3 medians meet, so I know that's called the centroid, because those are all medians. This is equidistant. Oh, this is a good one. I like this one. Equidistant to every side. So I could draw the circle in there to show that it's the incenter, equidistant to the sides. That one stumped a lot of people in class. And then this one's 3 altitudes. So the altitudes meet at the orthocenter. And this is, whoa, okay, this one's equidistant to every vertex. So hopefully you remember which one's equidistant to each vertex. Equidistant to the vertices. And that is the circumcenter. All right. Study. Bye.